This video is meant to chat through how to balance equations. So I'm looking at the PowerPoint that we went over in class. It's also linked within the study materials for final exams. And this is the slide that I'm zooming in on. This is the order in which that we need to go in order to balance an equation. So we do nonmetals first, then metals, then polyatomics, then hydrogen, then oxygen. Okay, so that's the order that we're going to do. I'm going to go through a couple of the trickier questions on this review guide. Okay, so the first one I'm going to go over is number 5. And the first thing that we need to do is we need to just take note of what the actual, and this should be a line like that. We need to take note, and I'm noticing a bunch of these are messed up. I'll fix this before you all see this. But okay, so first we just list out all of the atoms that are present. So we have sodium, we have chlorine, beryllium, and fluorine. And we need to make our atom inventory, okay? So on our reactant side, we have 1 sodium, 1 chlorine, 1 beryllium, 2 fluorines. On our product side, we have 1 sodium, 1 fluorine, 1 beryllium, and 2 chlorines, okay? So we go to our metals first, and both fluorine and chlorine are metals. So I'm just gonna do chlorine first. So in order to balance chlorine, I need to put a 2 here, and then I make sure that I distribute that 2. So I now have 2 sodiums, and I now have 2 chlorines, okay? Now sodium is now unbalanced, but sodium is a non-metal. Sodium is a metal, so I'm going to still go to my other metal first. My other non-metal first, I'm misspeaking. Okay, so we're going down to fluorine, and I'm gonna put a 2 here, and then I distribute that. So that gives me a 2 for sodium and a 2 for fluorine, and we're done with that one. So the next one I'm going to do is number 6, and my copy is all kind of goofed up, so I'm just going to do like this. Okay, so this one is really hard. I'm going to put a star by it. This one is tricky, okay? Anytime you see an equation where the products are water and carbon dioxide, this is a combustion problem, and these problems are typically hard because we see oxygen in 2 different places, okay? So that's kind of just a cue that this is going to be a more difficult problem than like the typical problem, all right? So same thing, we still just start by listing off, we have carbon, hydrogen, and oxygen, and then we do an inventory. So I have 2 carbons, I have 6 hydrogens, and I have 2 oxygens on my reactant side. And then on my product side, I have 2 hydrogens, I have 3 oxygens, because I have 1 oxygen here, and then 2 oxygens here. So that's a total of 3, and then I have 1 carbon. Okay, so if we go back to PowerPoint, again, we are going to do nonmetals. So we're going to first do carbon, and then hydrogen, and oxygen is last. And this is really important that we're following this order with this problem. Okay, so I'm going to start with carbon. And whenever you're doing this, you want to focus on the atom that you're balancing and no other atoms. Okay, the other atoms just don't really matter at this point. So first I'm balancing this. So in order to do that, I need to multiply this by 2. So I put a 2 here. And that gives me 2 carbons. But that also changes the number of oxygens that I have, okay? So I have 2 times 2 is 4. So from my carbon dioxide, I have 4 oxygens, and I still have this 1 oxygen here. And so that makes that a 5, all right? I feel like a lot of times as we're changing these others, we get stressed and we try to jump ahead. Do not try to jump ahead, okay? All right, this next one, we have 6 and we have 2. So we're going to have to multiply this 2 by 3 in order to get it balanced. So I put a 3 here, and that gives me 6 hydrogens. That also changes the number of oxygens that I have, okay? So remember, I have 4 oxygens from here, and now I have 3 oxygens from here, which means I have a total of 7 oxygens. Okay, so the next thing that we want to do a couple of things here. You can either multiply this by something to get it to be exactly this, or you can determine that the least common multiple of 2 and 7 is 14, so you can up that. But if you do that, you're going to have to change other things as well, okay, because you're going to have to change the side as well. So I think the easier way to do this is to multiply this number by 3, or to multiply the oxygen by 3.5, get this up to 7. Everything is balanced now, but we can't have 3.5 moles of oxygen gas. We have to have solid numbers. So we multiply the entire thing by 2. So multiply that by 2, multiply this by 2. So we end up with a 7 here, multiply this by 2, and multiply that by 2. Okay? And then as we're kind of going through this, okay? So everything is still balanced, but now we don't have any decimal points. That's why this one is, that one's a pretty tricky one. Okay. Just kind of a heads up on this, the tricky one, like you're most likely going to see one of those on your final. Okay, so just be prepared to do exactly what I was doing there. Okay. All right, so this next example, and again, this is all goofed up. This should be an equal sign, or a yields sign rather. Okay, so number 8, again, we just want to count out how many we have. So we have silver, we have iodine, we have iron, and then if we look, we have a polyatomic. Do you see how the CO3 is exactly the same on each side? Okay, so 1, 1, 2, 3, because we have 3 of the CO3s. Okay, and then on this side we have 1, 3, 2, and we only have 1 of the CO3s. Okay, so just like before, coming back here, we're going to start with nonmetals, and then go to metals, and then polyatomics. Okay. All right, so our nonmetals. So I'm just going to start with iodine. Okay. So I need to multiply this one by 3, so put a 3 there. So silver becomes 3, iodine becomes 3. The next one I want to do is, now I move on to my metals. So I can either do silver or iron. I'm just going to start with silver because it's at the top. For no other reason, I'm starting at silver. Okay, so the least common multiple of 3 and 2 is 6. So I need to make this a 6. And I'm going to do that by multiplying this 3 by 2 and having this be a 6. Okay, so that also changes my iodine to a 6, which I'm going to worry about that in a second. I want to make sure I'm distributing all these things correctly though. So on this side, I'm going to need a 3 here, because then this becomes a 6, and then that becomes a 3. So now my iodine is unbalanced, so I'm going to go back and fix that. So if I multiply this by 2, this becomes a 6, and then this actually becomes a 2, and that balances it. Okay? There are a bunch of examples of how to actually balance equations, and lots and lots more practice on YouTube if you're looking into it. Okay?